The word bomb comes from the Latin word bombus, meaning something that booms. It's thought it was the Chinese that created the first ever bombs with explosives inside a harder metal shell way back in the 13th century. But these powerful explosives will be remembered mostly for causing havoc during the Second World War, when Germany and Britain were butting heads in their respective aerial bombing campaigns. The Unabomber made small explosives that would explode upon opening a package, and terrorists leave them at the side of roads. But there are bombs so powerful that we don't even want to use them, and that's what we'll explore today. We'll start with the atomic bomb. You might have heard of this kind of bomb and have probably seen pictures of the devastation it can cause. This is the type of bomb that was dropped on the Japanese cities of Hiroshima and Nagasaki in 1945 by the Americans. Make no mistake, the British were behind this plan and also very much involved in the process. It's said around 80,000 people died instantly in Hiroshima after the bomb, known as Little Boy, was dropped, and more than double that died in total, mostly due to radiation. In Nagasaki, the bomb, nicknamed Fat Man, instantly killed around 70,000 people. So, how did scientists create something so deadly? Well, you see, scientists for a while had known that you could potentially create a huge amount of energy from little matter. Albert Einstein knew that, but it wasn't he that created the atomic bomb. Apparently, the Germans thought this was possible, but the British had already formed a committee and published something called the British Maud Report, which detailed the feasibility of creating an atomic bomb. The scientists wrote that it was possible to create massive amounts of TNT from a small ball of uranium-235. A report called Use of Uranium for a Bomb was written, which was given by the British to the USA. Soviet spies also got their hands on the report. This is how it all began. The Americans invested lots of money in actually creating this bomb, and that was under the aegis of the government's Manhattan Project. Many people took part in this, including military engineers, MIT scientists, the company DuPont, and a couple of ace physicists called J. Robert Oppenheimer and Enrico Fermi. So what did they discover over at the Manhattan Project? They found that they could create a massive explosion by what in layman's terms became known as splitting the atom. This is known as nuclear fission. Today you should remember two words: fission, splitting something, and fusion, joining something. As for nuclear fission, one anti-nuclear website describes it like this: the nucleus of an atom is split into two smaller fragments by a neutron. This method usually involves isotopes of uranium or plutonium. Neutrons split from the nucleus and energy is released, and then these neutrons hit other uranium or plutonium nuclei and they also split, further yielding more energy and more neutrons. This produces a powerful and instantaneous chain reaction that can produce something like 15 kilotons and 20 kilotons of TNT. It sounds simple, eh? But as you know, few countries are capable of doing it. Those include the United States, Russia, the United Kingdom, China, France, India, Pakistan, Israel, and North Korea. It's hard because first you need your material, which includes weapons-grade uranium. As you've seen in the movies, getting your hands on this stuff is not easy. Besides that, you then need scientists clever enough to understand the process of making a bomb, and you also need to spend tons of money on missiles that can carry the thing. So, let's say someone has gotten hold of this weapons-grade uranium. Can they make a bomb? Live science tells us that to create this chain reaction we just talked about, scientists have to create something called a supercritical mass to hold the atoms. It's this state that allows the chain reaction to happen. A supercritical mass is formed in a uranium bomb by initially storing the fuel as separate subcritical masses to prevent the bomb from detonating too early and then joining the two masses together, said Live Science. It's also difficult to make the bomb in a way that will allow this chain reaction to take place before the energy causes it to fail. This tricky process, and the fact that getting the raw materials is so hard, is the reason so few countries have these things. Now you're thinking, they haven't even answered the question yet. Well, we kind of did before, when we told you the definition of the word fusion. A hydrogen bomb is not a fission bomb, but a fusion bomb. And besides the difference in how the H-bomb is made, another difference is that it is much more powerful. Time magazine tells us the H-bomb could potentially be 1,000 times more powerful than the atomic bomb. A scientist told Time magazine that to make one of these, you need to first master the atomic bomb. To make it, using a simple recipe formula, you still need that uranium or some plutonium. You then throw in some deuterium and tritium, which are isotopes of hydrogen, and the magic happens when you fuse atoms together rather than split them. You need really high temperatures to cause this fusion, and that's where you get the name thermonuclear bomb. Voila! mankind's piece de resistance in the age of possible annihilation. It's said they are even harder to make, but lighter, so they can travel more easily on the back of a missile. Thankfully, no one has dropped one of these on people, but the USA and Russia both tested these megabombs in the 1950s. This was shortly after two scientists in the US, Edward Teller and Stanislav Ulam, created it. It's also believed that Britain, Russia, China, and France have conducted hydrogen bomb tests, and the jury is still out on North Korea. If you want to know what happened immediately after the atomic bomb was dropped on Hiroshima, Life magazine reported it in 1945 like this. In the following waves, people's bodies were terribly squeezed, then their internal organs ruptured, then the blast blew the broken bodies at 500 to 1,000 miles per hour through the flaming, rubble-filled air. Practically everyone within a radius of 6,500 feet was killed. After hearing that, imagine what an H-bomb could do if it's 1,000 times more powerful. The website NukeMap believes that if such a bomb was dropped on New York, right on top of New York City Hall, it would result in 385,660 deaths and 632,540 injuries from the blast alone. Fires would burn, everything would be destroyed around the blast site, with destruction reaching as far as New Jersey. Radiation would then get to work, and NukeMap believes the death toll would be about 792,630. Imagine bombs were dropped on lots of American cities, and you have a fallout that would affect much of the country. Well, we'll leave you with that sobering thought. Do you know what to do in the case of a massive emergency? Maybe in the event of something more realistic than a nuclear fallout, like an earthquake or a flood.